Hi guys, so for this review I chose a research article called Morphometric Analysis of Dog Bite Marks in Experimental Study. I provided the citation below as well as the authors. It was published in March of 2025 and can be found in the Forensic Science International Volume 368. Dog attacks on humans is a global issue with significant health and medico-legal implications. It can create punctures that make distinctive lesions and depressions on the skin. Two groups that are most affected are the actual animal owners, which are the family members and children, and the second group are people over 70 years old. A dog's dentition is influenced by two factors. The first is their teeth. Dogs have 42 permanent teeth, 20 in the upper arch and 22 in the lower arch. These consist of canines, incisors, premolars, and molars. The second is their cephalic index. You get this index by multiplying the cranial width by a factor of 100 and then dividing it by the cranial length. With this, you get three classifications of dog skulls: dolichocephalic, mesocephalic, and brachycephalic. For dog bite comparisons, this is comparing the morphological and morphometrics of the suspected dog's dentition and its depression on the skin. It's a very intricate process influenced by many factors and consists of two main parameters. The primary parameter is the inner canine distance. This is the space between the two canine teeth and is influenced by skull size and breed. The second is the inner dental incisor to canine distance, and that is the space between the cusps of the canines and their adjacent incisors. How does this help the audience understand the purpose of the study? So in bite cases, forensic analysis is often used in the victims to identify suspected dogs, and even though these cases are fairly common, there's a lack of studies conducted on human tissue. This undermines the confidence of drawing correlations between morphometric measurement methods and the skin lesions created. By conducting this comparison, the authors gather data that can be utilized for improving these methods, as well as aid the different forensic specialties and veterinary sciences that are involved. Like I previously stated, there are no studies analyzing bite marks on human tissues. Another gap the authors mentioned was the need for studies that compared multiple specimens of the same dog breed. This would allow for comparisons on which dog breed creates the most reliable dentition bite mark. The study also has limitations on representing real-world scenarios. There was inconsistent pressure of the dog's dentitions applied on the skin samples. They couldn't analyze vital tissue samples, so there was no bleeding, inflammatory responses, or post-mortem changes that could be observed. An ideal and complete impression are not likely in this real-world situation. Often it's only canine impressions or wound tears influenced by factors like movement, the location of the wound, the resilience of the tissue, and the pressure that's applied. Although these were limitations of the study, they also were useful for forensic insights as well as beneficial for the consistency of the experiment. The purpose of the study was to conduct a morphometric comparison between the dental measurements of canine teeth from 20 different dogs and the skin lesions produced on human tissue. I identified the hypothesis to be that the inner canine and incisor to canine dental measurements will correlate to the measurements on the bite marks created on the human samples. They collected 20 dogs from veterinary necropsies that differed in size, breed, and cephalic index, as well as amputated human limbs from orthopedic and vascular surgery departments. To create these bite marks, they applied the upper and lower jaws perpendicularly to the skin until the canines penetrated it. Like previously stated, the pressure was not measured nor consistent. They took the inner canine and incisor to canine measurements in both the dog's dentition and the skin samples. It's also noteworthy to add that they were measured 3 times and calculated the average of them. Photographs were also taken of the teeth and bite impressions, and the number and characteristics of the teeth and the characteristics of the lesions was also observed. STATA 18 was used for all statistical analysis. Stratified analysis were the dental arch, cephalic index, and the side, so left or right, if that was applicable. Paired t-tests showed the mean difference between the teeth and the bite mark distances, and Lin's concordance correlation coefficient evaluated the agreement between these measurements. For the intercanine distances, it measured 21 to 52 millimeters for the dentitions and 20 to 53 millimeters for the skin. It also had high agreement for all the intercanine measurements with a p-value of 0.001. For the incisor to canine distances, it measured 5 to 21 millimeters for the dentitions and 4 to 21 millimeters for the skin. It had a high agreement only for the lower arches and brachycephalic skulls. Some morphological observations were that the canines made circular puncture wounds and the incisors made circular or rectangular skin depressions. Intercanine distances are the main tool for forensic analysis when comparing bite marks to dog dentitions. It produces a more precise evaluation because of its greater length and the unique shape of the canine cusps. Interdental incisor to canine distances is useful when the previous measurement produces a similar or inconclusive data. Its main application is pack attack scenarios, where the intercanine measurements are identical and the suspected dogs have brachycephalic skulls. Morphometrics is not 100% reliable, and if the two measurements overlap, genetic analysis is required to evaluate the salivary biological material of the dog. I wanted to show examples of the photographs the authors took. Both images on the right side are taken from Figure 3, where they compared brachycephalic skulls, and then the left image is from Table 1, where you can see the variation of dog breeds, cephalic indexes, and dog sizes. They didn't just gather dogs that were labeled dangerous, but a wide variety in order to have a broad and diverse range of data. Does the study represent an inter, multi, or transdisciplinary approach? So it represents a multidisciplinary approach. It's not the full integration of techniques and ideas from different disciplines to create a new understanding, but it's utilizing these disciplines to work towards the overarching goal of dog bite identification. The authors called for the collaboration between forensic pathologists, forensic dentists, anthropologists, veterinary medicine specialists, and geneticists. Like I said in the previous slide, morphometrics cannot be used to solve this complex problem alone. The collaboration amongst these disciplines and their own expertise are needed. So I provided the source again. Thank you.